Building on architecture, blueprints, and high-level designs, you now step into the artifact that delivery teams live with every day. Solution architecture design is where enterprise intent becomes a buildable design that can scale under real load and stay supportable under real operational pressure. When you do this well, you deliver solutions that teams can run confidently, leaders can defend confidently, and customers can trust consistently. With that context set, you should treat solution architecture design as the full shape of a solution, not a diagram. It explains how the solution meets business outcomes, how it fits enterprise standards, how it manages risks, and how it will be operated over time. It also creates a shared understanding between product engineering, operations, security, and leadership, so delivery is aligned and trade-offs are explicit. Now that you know what it is, you can focus on the true goal of solution architecture, scale, and supportability. A solution that delivers features but fails under load, fails during incidents, or fails to meet compliance obligations becomes a business liability. You design solutions that can grow in usage, handle failure gracefully, be maintained over time, and be supported by teams who did not build the first version. With the goal clear, you begin solution architecture by anchoring on outcomes and constraints. You clarify what success looks like, what must not break, what must remain protected, and what operational expectations must be met. You also confirm constraints such as legacy dependencies, contractual obligations, skills availability, and regulatory requirements. Because constraints shape your design more than preferences do. With outcomes anchored, you now define scope and boundaries. Because most solutions fail due to uncontrolled scope creep. You clearly state what the solution includes and what it does not include. You define system boundaries, responsibility boundaries, and ownership boundaries, so teams do not assume the solution will solve problems it was never designed to solve. Clear boundaries are not limiting. They are what make delivery possible. With boundaries defined, you now use a small set of architecture views to make the solution easy to understand. You describe context, main components, major data flows, integration points, trust boundaries, and operational responsibilities. Each view exists to answer a question. What is connected? What is trusted? What is sensitive? What is critical? And who owns what? When you keep views purposeful, your design becomes readable and defensible. With views in place, you now focus on scalability as a deliberate design dimension. Scalability is not only about handling more users. It is about handling growth in transactions, data volume, integrations, and operational complexity. You design for scalability by ensuring the architecture can expand predictably, isolate stress points, and avoid single points of failure. You also avoid over-engineering by scaling what matters most, based on expected demand and business criticality. With scalability considered, you now treat resilience as a core requirement rather than a nice extra. Resilience means the solution can handle failures, recover quickly, and continue delivering essential services during disruption. You define failure modes, recovery expectations, and the design choices that prevent small issues from turning into major outages. When resilience is designed upfront, the solution becomes easier to operate and less costly to repair later. With resilience set, you now focus on supportability because the strongest design is the one operations teams can sustain. Supportability means monitoring is meaningful, alerts are actionable, ownership is clear, and changes can be made safely. You design for supportability by defining operational responsibilities, incident response expectations, change control realities, and service ownership from the start. A supportable solution reduces fatigue, reduces downtime, and protects the organization's reputation. With supportability established, you now design observability as the way teams understand what the solution is doing. You ensure the solution produces the right signals for performance, reliability, security, and business outcomes. You also ensure that operational teams can trace issues across dependencies, understand customer impact quickly, and respond confidently. Without observability, support teams rely on guesswork and outages last longer than they should. With observability in place, you now embed security by design in the solution architecture. You define how identity and access are controlled, how privilege access is governed, how data is protected, and how trust boundaries are managed. You ensure monitoring supports detection and investigation, and you ensure security responsibilities are clear after go live. Security is not a separate work stream. It is part of the solution structure and operating model. With security embedded, you now focus on data and integration because these are the areas where complexity grows fastest. You define how data flows, where sensitive data resides, and how data integrity is maintained across systems. You design integration boundaries and interface responsibilities so changes can be made without breaking the entire ecosystem. When data and integration are clear, scaling becomes possible and supportability improves dramatically. With data and integration map, you now connect design to experience because leaders and customers judge the solution by how it feels. You define performance expectations, response time targets, and how performance will be maintained under load. You also consider the user journey across dependencies because a solution can be technically correct but still feel unreliable if integrations are slow or inconsistent. A scalable solution must also feel consistent to users. With experience in mind, you now ensure the design is defensible under scrutiny. You align the solution to required controls and governance expectations relevant to the environment. You document key risk, mitigation strategies, and any residual risk acceptance pathways, including exceptions that must be reviewed over time. This ensures the solution can survive audits, incidents, and executive questioning without panic. With compliance addressed, you now make trade-offs explicit because hidden trade-offs become future conflict. Every solution involves trade-offs such as cost versus resilience, speed versus control, and flexibility versus standardization. You document what you chose, what you rejected, and why, so the organization can defend decisions later and revisit them intelligently when conditions change. Trade-offs are not a weakness. Unspoken trade-offs are the weakness. With the full design approach in place, you can now bring it to life in a realistic example. Imagine you are designing a digital customer service solution expected to grow rapidly. You start by confirming outcomes such as reduced call volume, improved customer satisfaction, and stronger compliance posture. You define boundaries so it is clear which systems remain systems of record and which services are customer facing. You design scalability by ensuring the solution can handle peak demand predictably. And you design resilience by planning for dependency failures without losing critical customer functions. You embed observability so operational teams can detect issues early and understand customer impact quickly. You define security by design through strong identity controls, privilege governance, and data protection. You then document trade-offs, such as choosing staged capability rollout to reduce risk and ensure operational readiness at each step. This is what solution architecture looks like when it scales and stays supportable. As you close the lecture, you should recognize the failures that create fragile solutions. Solutions fail when boundaries are unclear, when non-functional requirements are assumed rather than designed, when observability is missing, and when operational ownership is vague. They also fail when security is treated as a later task, when integration complexity is underestimated, and when trade-offs are hidden to avoid difficult conversations. You avoid these by designing for production reality from the beginning and by making decisions explicit. Let's now discuss the key takeaways from what you learned so far, so you can create solution architecture that scales and stays supportable. Solution architecture design turns enterprise intent into a buildable design that delivery teams can implement consistently and operations teams can sustain confidently. You start with outcomes, constraints, scope, and boundaries. Then use a small set of purposeful views to make the solution understandable and defensible. You design explicitly for scalability, resilience, supportability, and observability, because these are the dimensions that determine success after go live. You embed security by design, clarify data and integration responsibilities, and ensure compliance and risk are handled transparently with documented trade-offs and residual risk pathways. A strong solution architecture is not defined by complexity. It is defined by clarity, defensibility, and long-term operational health. As you move into the next lecture, start judging solution architecture by one standard. Can it scale? And can it be supported by real teams under real pressure? Subscribe to the channel so you do not miss the next videos in this playlist. Like this video so it reaches more leaders and architects who want to design solutions that succeed after go live, not just at approval time. Comment with the biggest challenge you face in solution architecture design, whether it is scaling, operational readiness, integration complexity, or making trade-offs visible. Share this video with someone working on solution design, because scalable and supportable architecture is one of the most valuable skills in the market right now.